So it's
That's what my kid did.
Okay. So you had a chance to look at this. Which groups are ready to vote?
We're ready.
All right, let's go for it. Okay, zero acceleration. Okay, who thinks that at point A there is zero acceleration? Who thinks at point B there's zero acceleration? Who thinks at point C there's zero acceleration? 1, 2, 3, 4, 5 groups. Who thinks that at point E there's zero acceleration? Who thinks points A and C have zero acceleration? And who thinks points A, C, and E have zero acceleration? Okay, one group abstained. That's fine. All right, so for the groups that voted, why did you guys say that there's zero acceleration at point C only?
The constant speed, and I go in a straight line, so there's no acceleration.
Okay.
Always acceleration in a corner, though.
Okay, so on the corners there's acceleration. Do you guys remember what terminology we called that?
centripetal acceleration.
Yes, centripetal acceleration, radial acceleration, all good words. Great. Any questions? Okay, moving on. Pendulum swings back and forth. It reaches a maximum angle of 45 degrees. Which arrow shows the direction of the pendulum bob's acceleration as it moves from left to right through point Q?
It's always going to have it's always going to
So then if you average the two, you have, the line going directly in.
does that make sense?
So there's your average, there's your X, there's your Y.
We don't have acceleration is zero.
Yeah. You're always
The only thing is the screens are down, so does that change?
It's weird because you're not getting
Acceleration and vertical direction, horizontal direction.
accelerating.
Okay, how many groups have come to some sort of consensus? 3 groups? 4 groups? Oh, yeah.
Where do you guys go?
I'll give you guys a few more minutes, or 8 minutes. You guys done?
Yeah.
Okay. Over here, you guys are still debating? Debating. Okay, we're gonna go ahead. Who thinks that the answer is A, acceleration is to the left? Who thinks that it's B, straight up? 1, 2, 3, 4 groups. Who thinks that it's C, to the right? Oh, 5 groups? 5 groups, okay. Who thinks that it's D, straight down? 1 group. Okay, so we've got 5 groups that say it's up and 1 group that says it's down. So we'll start with the up camp. Why did you guys choose up? Those who chose up.
Because it goes to the inside of the corner. It's just, if you go through a curve, it would be going to the inside of the curve with the car, unless the string changes it. That's what I was going with.
Okay, Chris?
Isn't radial acceleration always towards the center of the arc?
Okay, did other people agree with that? Okay. Okay. All right, anything else you guys want to say about why you chose up? All right, this table over here.
I think we'd like to switch.
All right, you guys are swayed? Not yet.
I like gravity. Where does gravity fit in? Acceleration due to gravity. Isn't gravity pulling on it?
Because the thing is that the speed isn't constant. it's gonna be slowing down over time due to gravity. And so you can't necessarily apply the same, centripetal acceleration trait that we've been using for uniform circular motion. Uniform circular motion says the acceleration is only towards the center if the pendulum or the thing in the circle is going at a constant speed. If it's going slower over time, it's gonna be, the acceleration is gonna be slightly behind where that right angle would be. And then when it's going at a gradually increasing speed, the acceleration is gonna be a little beyond that right angle. So ultimately, because the speed is slowing down, it cannot be the answer to.
But I won't disagree with you there, but we don't have another option, right? So
Right.
you're saying that this pendulum is slowing down, and so what we learned is that the acceleration would actually be slightly to the left. Yeah, so I don't disagree with that. I think this is kind of practical. Because you're right. It's not going at a constant speed around that curve. Now, to Gavin's point, that gravity is acting on it downwards, you are correct. And this is it's a little bit of a challenge, because when we talk about the pendulum's acceleration, we're talking about its net acceleration. So there is the gravity component acting on it, but there's other stuff too. The tension force pulling up on it, and the net acceleration would be upward. Yeah, and we're gonna hit that really hard today with the forces, where we talk about all the different forces that are acting, or what's the net effect. Yeah. So you guys are still, thinking good thoughts. Yeah, Rachel?
I was kind of thinking, like he mentioned that it would fall inward, like if we cut the string or something. It sounded like at least that it would fall inward. I was thinking it would fall outward, because I'm assuming the pendulum's hanging down. So it's swinging this way. it should
All right, I
fall.
wasn't even thinking about that.
It would change.
Okay.
It would change the move.
So that's a good question for everybody. If the string were cut right at this point, it's swinging along this arc, what direction would the pendulum fly if we cut the string?
It would go a tangent to the corner, right?
Yeah.
The
So
curve?
I got multiple people doing that, so, yeah, so it's gonna go tangent, but of course, it's being acted on by gravity, so it will start out tangent, and then it would be a nice projectile, actually. If there was an easy way to do that experiment, wouldn't that be cool? Yeah. Have it just cut right at that point, and then,
Instead of a razor blade, so that when it drops.
oh, yeah.
Actually, a magnet would do it. That way you'd have it more exacting.
Yeah, so there was something, so just disconnect
But
the magnet
immediately,
right
yeah,
at
but
that point.
the problem with the razor, I think, is gonna give you too much resistance, so
Yeah.
magnet's gonna give you the least amount of resistance, for sure.
Unless we use a laser.
Ah.
Oh,
You mean a laser?
nice. All right, so anyway, I think everyone's on the same page with this problem. So the correct answer was B. So we're moving on. A projectile is launched at a 30-degree angle above the horizontal. Ignore air resistance. The projectile's acceleration is greatest at what point? Here's all your options.